Okay, hello everybody. Good morning. Welcome to Calculus. Can you hear me? Can you put something in the chat? Let me know that you can hear me. All right. Good morning, everyone. Steve, Zhonghua, Kyle, hello. Madhav, Azalea, Hazel, Eric, hello. Nai Peng, Brett, Nicole, Serena, so many. Hello. Welcome to day one of term 3. So if you're new to the university, welcome. And if you're continuing your studies, well, I hope you have a good time with us here today. So I'm Chris Tisdale. I'm a professor here at UNSW, and I will be teaching the calculus part. Okay. And the nice thing about calculus is that some things will be familiar and some things will be new. So the first lecture today is quite introductory and quite basic. Okay. So let me know what's happening in the chat. I also give some tutorials like today and on Thursdays. So I'll put those in the chat for you if you want to come and join my tutorial. And look, I look forward to learning with you and you know, you achieving the marks that you want to achieve. Okay, so let me share my screen and let's have a look. So let me share my screen here. And I'll just go here. So just give me a second. Oops, no, that's not what I wanted. Share screen. Okay, so you should be able to see my big fat head now. Yeah, hello. Okay, and what I'll do is I will use my document camera. So I like to use my document camera and a pen, and these notes are available on Moodle. Okay, and so the idea is you download the notes and we go through the problems together. And you can just fill in the blanks with your pen or on the screen or whatever you want to do. Okay. Yeah, I've got a few friends here in the background. Good pickup, CZ. Yeah, I might be joined by a few friends this term, so keep an eye out. So I'll come back to Mario in a minute. So the first topic we're going to look at is functions. Okay, and it's a basic introduction, and I suspect most of you will have seen functions before. The difficulty is not particularly high for this one. Okay, and we're just going to go through and look at the following ideas. You know, what is a function? What is the domain and the range? What is a relation? And how you compose functions. So you bring functions together. Okay, like a combination of functions. So it's a very laid back introductory lecture. Okay, but I hope you enjoy it, and I'll try to make it as interesting as possible. Okay. All right. So this is what we'll be talking about today. So why do we need functions? How do we represent functions? The basic sets of associated with the functions and how we combine functions. So it's pretty easy, right? Okay, so let's just refresh our memory here, because I'm sure some of you are going, come on, Chris, it's 2 a.m. here or 8 a.m. I know all this stuff. So let's just refresh our memory. Okay, so function is a rule. Okay, that's the most important thing. And the rule relies on some sort of input, and it produces an output. So if you had like I don't know, like a schematic diagram, right? Like a machine, right? Your input goes in here. Okay, that's usually, we usually let that be X. Not always, but most of the time. You've got a rule. We denote that by F. And the output is denoted by F of X, or sometimes Y, right? You can write it like this as well. Okay. And so this thing here might be called a function machine. Okay. All right. So the steps are we input something, the machine processes the input at this stage based on the rule, whatever F is, and the machine produces an output. Okay. Pretty easy. Pretty easy. Okay, so that's all functions are. And, you know, you can have lots of different functions. Like you could have a function that squares the input. Okay, you could have a function that doubles the input and adds 1. Okay. You can have something that takes the input and it divides it into 1. So these are all really common, basic examples of mathematical functions. Okay, so nothing too crazy there. All right, so why do we need functions? Well, I am glad you asked. So let's think of something similar, right? They're a bit like formulas. Okay, and what functions help us to do is they help us to understand, model, and solve problems. They also help us to predict what's going to happen. Okay, so as a really simple example, and this is super, super simple. Suppose we have a square, okay, and we want to know how the area of that square changes with respect to the length of the side. Okay, so we all know that you can just square the length of the side and that gives you the area. So this is an example of a function here. Okay, the input is the length of the side. The actual rule or the function is the squared, and the output is the area. Okay, pretty easy, right? Pretty easy. Let's go back to my big head for a second. That one should be all right. Pretty easy. Okay. So functions help us understand and describe things. And we're going to use them a lot in the calculus because we're going to be differentiating, we're going to be integrating, and we're going to be working with functions. So they're really important, okay? All right, so let's go back to the document camera. All right, so pretty easy so far. For the function notation, we usually, not always, but we usually let X be the input, sometimes called the independent variable. It doesn't depend on anything. It's completely free. Okay. F represents the function or the rule, and the output is f of x. Okay, so here are some more examples of functions. Okay, now these are all kind of algebraic expressions, but you can also use graphs, of course, right? So you can have, say, an x-axis and a y-axis, and I don't know, here's your function, let's say, and each point on that graph satisfies whatever function whatever rule we're drawing. Okay, so you can describe functions using this sort of algebraic notation. You can also represent functions using graphs. Okay, and sometimes you want to go between the two. Okay, all right. Yeah, so when I talk about things like points in the plane, so let me see if I can do that. Yep. So this point here would have coordinates x, comma, f of x. Yeah, or simply x, comma, y, because I know some people, they like writing y equals f of x. Yeah. Okay, so we can do it algebraically. We can also do it visually using graphs or sets of points. Okay, no worries. So they're what the basic ideas behind functions, why we need them. Let's actually do a few examples, and we'll talk about these ideas. So domain, codomain, and range. Okay, and I'm assuming that you will have seen these kind of ideas before, but let's revisit them. Okay, the ideas here are probably a little bit more formal than what you've seen before. Okay, all right. So there's three things. These letters here represent sets. Okay, sets of numbers or sets of points for us. Okay, so A would be a set, B would be a set, and the notation F, it says basically it takes the inputs of all the points in set A and it produces an output. Okay, so it takes, this is your input and this is your output. Okay, so what this means is X is an element of the set A. All right, or X belongs to the set A. All right, so this set is known as the domain, and we write it like this. This set is known as the codomain, and we write it like this. And then the range is actually all the points that are actually produced. And I'll show you what I mean by that in a minute. Okay, so there's three things here. The input, which is a set, the possible outputs, which is another set, and all the achieved outputs. So why is this important? Well, let me just go back to my big head for a second. There. So when we look at functions, it's really important to understand what kind of input can I do with the function? What kind of output am I going to get? Okay, so for example, if I have a CD and I try to put it in a computer, maybe the format isn't right and I can't actually put it into the computer. It's not really a proper input. Okay, that's an example where you have to really be careful about what you're trying to put into your function or your machine. All right, so domain, codomain, range. So let's have a look at some examples. Before I do that, I've broken this down a bit more. So when we talk about domain, we talk about allowable inputs. You can't, like, so for example, if I had a function like this, who can tell me in the chat what x value can I not put into this function? Can anyone tell me in the chat? Come on, go ahead and smash that chat button. Ah, yes, 0, right? Why can't we put x equals 0 in here? Anyone know? You're absolutely correct. Why can't we put in x equals 0? Yeah, it's undefined. So for those people who are responding, thanks for nothing, right? Thanks for nothing. So here we would say x cannot equal 0. All right, the range is then the set of achieved outputs. Okay, that's a really important word. And the codomain is an announcement of everything that might be produced. Okay, the range is what is actually produced. Okay, so let's do an example and see how we go. Determine the domain, codomain, and range of this function given by this. Now, this is a super simple function, okay? So the graph, okay, it's x squared plus 2. So it's like a parabola that has been shifted 2 units up the y-axis, okay? Okay, all right. So the domain, is it okay to put any value of x in here from the set of real numbers? Who can tell me in the chat? Are there any problems with the domain? Yeah, you're absolutely right. So this is just a polynomial, so it's nice and friendly. So what I would say is the domain of f is just the set of real numbers. Okay, by this funny looking R, what I mean is the whole number line, the whole real number line. Okay, so that's what this funny looking R means. It's the whole real number line. Okay, what about the codomain? Okay. Okay, well, this is a real, like we input real numbers, we square them and we add 2. So the set that might be produced is, again, you can see it from here, it's just the set of real numbers, okay? Ah, yes, Steve, you're jumping one step ahead to the range, right? So you're absolutely correct. If you look at the graph, what actually is achieved in terms of output? Well, -2, -10, 0, they're not achieved, but as Steve said in the chat, 2 and above are achieved, okay? So what is actually produced? Well, the range of f is this, okay? Yes, Jingjun, thank you. Okay, so this is the notation that says the range is greater than or equal to 2, okay? Just like you've said there. All right, so this kind of notation is interval notation. You can also say, oh, that's fine. That's the funny set notation. Okay, so yeah, Abdul Rahman, the range and the domain can be the same. It just depends. We're much more relaxed with the codomain. It's a really good question. Okay, the way I think of codomain is, are we going to get a complex valued answer or output? Okay, so I sort of try to think about codomain as splitting it up between real outputs and complex or imaginary outputs. Okay, correct. And above, range is a subset of codomain. Okay, So you can say that range of F is a subset of codomain. Correct. Dijan, it depends what you mean by subset. Like here, it might be the same. It doesn't have to be a proper subset. Okay. Hira, that's a good question. In calculus, we're just talking about real valued outputs. Okay. Just real valued outputs. So we won't be worrying about things like complex valued functions. You'll see that next year in more difficult mathematics courses. Okay. Yeah, Steve. Well, I mean, you kind of get the codomain from here. If we go back to the definition here, you can see B is known as the codomain, right? So you kind of told that already. All right. So last part of this question. So f of 1, well, that's pretty easy. We just put in x equals 1. And this one's a slightly more difficult question. This wants us to replace x with w minus 3. Okay. And so if we expand that, we'll get that. Okay. So this function actually just shifts everything to 3 units to the right. So if you know this graph, it's very easy to draw this graph. You just shift it 3 units to the right. Okay. All right. I am loving the, let me go back to my big head for a second. I'm loving the chat, the activity in the chat, people. Keep it up. All right. I'm enjoying it. It means that people are listening, which is great. Okay, let's have a look at a different kind of question here. Very similar, but slightly different. Consider this function defined by this. It's the same function as before, right? But the domain has changed. Okay, the domain has changed, and we are artificially restricting the domain. Okay, just between -1 and +6. Sketch the graph of f and determine its domain, codomain, and range. All right, so let's have a look. So yeah, this will do. Okay, so we're only interested in the interval between x equals -1 and x equals +6. So I'm going to put those on the graph. And it's the same graph, but it's just on a smaller part. So what I can do is, let me find my pen, is just draw it like this. And it's going to look like this. Now, a question for the chat. Why do I have open circles there? Does anybody know? Why have I drawn these little open circles? Yes. Anthony, Naipeng, Dijant, and Hira. Yes. You can see here, this means with the open brackets, it means that the x is between 6 and -1. We do not include the endpoints, right? Yeah, so you're absolutely correct. Okay, so from this diagram, sketch the graph, determine its domain. Well, the domain is right there. That's not a difficult question at all. Yep. Right. Codomain, well, it's real valued. I'll put the brackets in. And the range, okay, so what's the range? Well, we know that that is 2. What about all the way up here? Let me extend that a bit. What's the value going to be up there? It's going to be something like 38, correct. Now, we include 2, but we don't include 38 because you've got an open circle there. Ba-ba. Yes. Okay. So there it is. So let me come back to my big head. So again, not very difficult, right? Like it's pretty easy. It's a pretty introductory ideas here. Okay. So there's been some really good questions in the chat so far. The 3 most important things that we've learned: domain, codomain, and range. Okay. All right. So let's go back and have a look at the next question. Abdul Rahman, that's a good question. What would they look like if they were included? Yes, Steve and Azalea are on the case. So 2's included, 38's not. As some have put in the chat, if 38 was included, you would do that. Okay. Now, don't ever do this. That's total. That's wrong. Okay. Wrong. Okay. Mamma mia, that's so bad. Don't do that. Okay. Because infinity is never a number, right? So you can never include infinity. Okay. Let's keep moving. Compute the domain and the range of this function. Okay. So this is a more difficult question. And what we like to do with these more difficult questions is look for problems. Okay. So one is division by 0. And the other one is when you take the square root of a negative number. Okay. Now, remember, this is calculus. Okay. We're not going to do things like complex numbers. You'll do them in algebra. Okay. So it's a little bit weird. In calculus, we ignore complex numbers, but you'll see them in algebra. But for our functions, they're all real valued functions. Okay, you can only put real numbers in and you get real numbers out. All right, so that's a problem for our functions. So what can we do here? Well, people are piping up in the chat. Great. So there's a problem when, as people are already putting in the chat, when you divide by 0, that's the case when x equals -3. So we can't have x equals -3. And we don't want to take the negative of, take the square root of a negative number. Okay. So if we combine this and we combine this, and we want to exclude both of those cases. Oops. The domain of f. All we really want is to have x bigger than, oops, sorry. Okay. Yeah, Advaita, we're only putting in, for these ones, we're only putting in real numbers, okay? And yeah, look, I wouldn't worry too much about codomain because it is a little bit uncertain, right? It is a little bit uncertain. So I wouldn't worry too much about it. So the next thing is, what about the range? Okay. So one way to help out with the range is to draw a picture. Yeah. So okay, so there's a problem when x equals -3. Okay. And if you draw a little graph, it's going to look something like that. Okay, this is going to be 1 on √3 or something. Okay, so from the graph, you can see, well, the points on the y-axis are all positive, yeah? They all lie above the x-axis. So the range, and some people have already put this in, would be that. Okay, thank you, Do. Okay. So one thing that helps me sometimes is to draw a graph. Well, how do you draw the graph of this? Well, it's actually very easy. What I like to do is draw the graph of 1 on √x, yeah? And then you shift it 3 units to the left. Okay, so that graph actually becomes that graph. You just shift it 3 units because there's a 3 there. There's a shifting. Yeah, that's it, Steve. If you can draw simple curves, you can get more complicated curves just by moving them left and right. Okay. Domain and range. Yep, not a problem. So these are the two main problems when we're looking at finding our domain, right? Division by 0 and taking the square root of a negative number. They're pretty, pretty standard techniques. Okay. All right. Now, one type of function. Yeah, Abdul Rahman, you can say that. Like if you want to use different notation, that's a really good question, Abdul Rahman. You could also say it's those real numbers there. Okay? That and that are the same. Okay? You could say, so I would write something like that just to be clear, Abdul Rahman. And here you could also say, you could say that. So this is interval notation. This is set notation. Interval notation, set notation. Okay? It's completely, let me go back to my fat head for a second. It's completely up to you. Okay, it's your decision, but you need to be aware of both kinds of notation, interval notation and set notation, because you'll see them, in different parts of your course pack. Sometimes they use interval notation, sometimes they use set notation. So my suggestion is to be consistent and just to be aware of both. Okay, so that's a really good question. Thank you for asking. All right. Oh, split functions. Okay. In this course, we will see split functions a lot. We will see them a lot. I keep banging the table. Sorry, I know it's moving the camera, right? If I go like that, I'll try not to do it. Okay, a split function is a function that has two or more parts to it. Okay, so you can see here, for these inputs, it's this line, and for these inputs, it's a different line. Okay, so here we've really got two different functions that are kind of put together. Okay, now these are not difficult things. We just need to remember what is going on here. All right, so I'm going to draw a picture first, and then we can see what's happening. All right, so the change happens at x equals 1. All right, so over here on the right-hand side of x equals 1, that's this function. Over here on the left-hand side, it's this function. Okay, so let's see if we can draw this and see what happens. Now, when x is close to 1, this is almost 9, right? And it's got this kind of curve. So that is really 4x plus 1 for x greater than 1. And over here, we've got 7 minus 2x. So when x equals 1, this is going to be 5, let's say. And then I've got the line 7 minus 2x going on down there. Okay. So this is a weird looking function. It's two parts that have been joined together in one definition. And here what I'll do is I'll just write this extra notation in. Okay. All right. So you will see lots of these kinds of functions. It's a line, and then maybe there's a jump and a different kind of definition. Okay. Now note I've got an open circle there because this is not part of the definition for x greater than 1, and I've got a closed circle there because that is part of the definition. Okay. So the 9, that's a really good question, Max. What I've done here is I've said, okay, this function here, what happens to this function at x equals 1? Oh, sorry. Oh, hang on. Oh, I've made a mistake. Let me correct that, right? So this should be 8. Okay. Whew. Thank you. Yeah. Sorry, that was a bit of a fail. So it should be an 8. All right. So let's go back here. And that's looking better now. Okay. So we've got a filled-in circle there, an open circle there. This is what we've got here, and this is what we've got here. All right. So let's work out f of 1, f of 2, and f of 3. Okay. So who can tell me what is in the chat? What is f of 0? Who can tell me from this crazy definition? What's f of 0? 7. Correct. Okay. What is f of 1? Who can tell me in the chat? Smash that chat button. It's 5. Correct. Thank you, everybody. And now that I've corrected that. F of tree. What is f of 3? Who can tell me? So we would go up here. 3 times 8 is 24 and add 1, 25. Okay. All right. So thank you, everybody. So back to my head. All right. So we're on a roll. We're doing well. What is the domain and the range? Let's forget about the codomain. The domain and the range. Put it in the chat button. Okay. Domain and the range. Who can tell us? Okay. All right, I see a few people coming through. Yeah, this table just keeps moving. All right, so domain is all the real numbers, correct? Because we can put anything into this and it'll be fine. So you're absolutely correct. So let's go R. And the range, yep, the range, yes, it will be greater than or equal to 5. Okay, that's it. Okay, so don't forget to include the 5 because we do have, it does actually achieve 5. Yes, excellent. Okay. Why yin? That is an excellent question. Okay, let me go back to my big. So that's an excellent question. Thank you very much. So the question is, why is the bracket open with the infinity? Okay, let me have a look at that. So why is that bracket open? Okay, the reason is we cannot include infinity. Okay, we cannot include infinity. Okay, like when I went back here, you can't include infinity here because infinity is not a real number. Okay, yeah, Azalea's got it. Infinity is not a number. Okay, so we cannot include it. Yeah. Okay, we're making great progress here, people. Making great progress. All right, a couple of things that I wanted to finish on. Sometimes we have functions that well, they're not really functions. They're more kind of relations, right? So sometimes we'll have a curve, let's say, that looks like this. Okay, that's my curve. Other times I'll have a function that looks like that. Okay, and these are different. Okay, you can see this curve bends back on itself. Okay, this doesn't. This just keeps on going, right? So if I was to draw any vertical line, it crosses the graph at most once. At most once. Okay, so you can see here's a point, here's a point, here's a point. Okay, maybe it doesn't cross it anywhere. Okay, this one is different. If I draw a vertical line there, aha. If I draw it there, then 1, 2, 3. 1, 2, 3. 1, 1. Okay. This is a test that we use to differentiate between relation and function. Okay, so basically you've got, with a function, you can write it as y equals f of x. With a relation, it's not possible. Okay. Yeah, that's excellent. If you have one input here, you've only got one output. If you have one input here, you have potentially 3 outputs. So that's right, dude. Excellent. Okay. So this is what I mean when I'm saying multiple possible x values for the relationships, which are not functions. Now, in this course, mostly we'll talk about these kinds of functions. These relations, well, I'll give you some examples, but you know, these are going to be more important than these. Okay. Okay. So, which of the following pass the vertical line test? Yeah, Abdul Rahman, that's okay. So that's a really good question. So the question is, what if multiple inputs give us one output? Well, let's look at this curve, the sine curve, right? That input gives us that output. That input gives us the same output. Okay, so that's fine. That's not a problem. Okay, so that's not a problem. But it's a good question. Okay, so which of the following pass the vertical line test? Okay, well, x squared plus y squared equals 9. That's just a circle with center at the origin and radius 3. Okay, so the question is, does this pass the vertical line test? Yes or no? It does not. Let me get a different color. I'm going purple. Okay, so if I draw that, you know, obviously, so this one, no. What about this one? 2x minus 6. Okay. Okay, Dijant, do. Venbo, Aditi, thank you. This definitely passes, right? Because if I draw any vertical line, it passes through at most once. Okay. Yes. Okay. Finally, what about this one? Let's go here. It's going to look something like that. So does this curve pass the vertical line test? Okay. Well, let's see. Boop, 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 boop. What about over here? Does it matter? Does it matter that it's not touching the curve over there? Definitely doesn't matter. Okay. So these are functions. This is a relation. Okay. This is a relation. We will mostly be interested in functions. Okay. Last idea. Combining functions. You can add them, subtract them, multiply, and divide. Okay. When you bring two functions together, we use this kind of notation, right? You can write it like this, or you can write it like this, or like this, whatever you like. Okay. Fog. Okay. Now the order matters. So if you reverse the two functions, they're not necessarily the same. Okay, so let's have a look with an example and then I can finish and take your questions. Okay, so here's an easy example. Here's a function, here's another function. combine them together. Okay, so let's do the first one, f of g of x. So basically you go to f, you replace x with cos x, right? And if we do it the other way around, okay, so that is g of f of x. So you take f of x and you put it into g, you replace x with x squared. Okay? So you can see these two things are not the same, not necessarily the same. Okay? So the order of operations matter. Oops, sorry. Okay? The order of operations matter. And yeah, when you, instead of having f of x here, you take g and you replace x with this whole thing. Okay? All right, folks, that is it for my part of the lecture. Yeah, Abdul Rahman, you can just write this if you want, but you will see this in the notes, okay? You will see this in the notes. So it's up to you. You know, you will see this kind of notation sometimes. All right? I think the most important thing is just to be clear and consistent. Okay, everyone, hit me with your questions. If you have questions about the course or the assessment or whatever, you know, we can do that now. Let me go back to my big head. So if you have questions, I'm happy to talk with for a few minutes. Maybe something's troubling you or you have some important information that you need. Now's the time, everyone. So let me know if you have questions in the chat. All right. Oh yeah, Mobius. This is a good question. Okay. So there's like 3 or 4 questions here, which are great. Okay. So let me show you what Mobius looks like. Okay. So Anubhav, I think this will be great if you can get it. So let me go to this. Okay, so one of the graphing things that I really like is GeoGebra. Okay, and GeoGebra is great because it helps you graph things, and you will be able to use graphing software in the final exam. Okay, so great for graphs. So Desmos is excellent, Max. I know there are some Desmos fans out there. Desmos is really fun too. So whatever you like, I would use that. Okay. So it's free and I really recommend it. And in particular, in lectures, I'll be using GeoGebra quite a lot. Okay. All right. Mobius. Let me show you Mobius. Right. So I'll stop sharing that. And I will share a Mobius screen. I think this is it. Let me see if I'm sharing correctly. Yep, there we are. Okay, so this is Mobius. I'll put the link in the chat. Okay, and you need to enroll in the class that's right for you. I suspect there will be a link in Moodle. Okay, so there's probably a link in in Moodle. Okay. So that's where it is. And you know, if you, I don't know, if I go into this one, this is just a random one. I'm not in our one today. Let's see if I can get in there. And sometimes it's very slow. Okay, while that's working, I'll do that. Okay, yeah, Michael, I think it's Michael. So yeah, you can. So this is where the you know, questions are and all that sort of stuff. So so that's it. Mike, I think is it Michael or Michelle? Will Mobius teach us to use Maple? Yes, yes, it will. One of the nice things about the assessment is you don't need to know any Maple. You just learn it as you go. Okay, so that's really good. So don't stress about that. The recording of today's lecture will be available probably later today. Yeah. Yes, Mariam, there is the calculus. Let me have a look. I'll just share that with you. Let me see if I can find it. So there is a place in, here it is. So you can see here, this is the Maple one. If you go down here, tutorials, right? Tutorial problems, week 1. Okay, so week 1 Mobius lesson, classroom tutorial. There are some questions there. Okay, and there's a tutorial sheet. Okay, so if you just have a surf around around Moodle, you should find it. Okay. All right. Nandan, I'm not sure about the Elise quiz. I would just try to do it I would just try to do it as soon as possible. Yeah, Carl, I'm not in the T3 Mobius yet, but I haven't enrolled in it yet. Okay, so that might open up, or it'll be coming. I'm pretty sure. Okay, the stuff that I can see on Moodle is maybe different from what you can see because I'm an instructor, right? Hannah, good question. What is the rule regarding attendance and passing the course? You just need 50% total. Okay, you don't need to attend the lectures, but obviously I would like to see you. But you don't need to attend the lectures. It's up to you. Okay. Mobius will like, there might be some tutorials about Mobius, but mostly you're expected to just do it at your own pace. If there's a big need, there could be some tutorials. Okay. Yeah, Jason, I couldn't find the T3 class yet either. When you're saying I can only enroll for the T1 class. Aichen, you just look at the course outline, right? Like it's all in the course outline. So let me have a look. Okay, so here it is. If you go here, course pack outline, right? Here it is. Okay, so this tells you everything, right? Okay, so this is, you can see all the syllabus and all the lectures and all the chapters. So that should be enough for you. So Aichen, I can't tell you the page number of the question booklets. You can just go and find the files on Moodle. Yeah, Dinith, Mobius is like self-learning. It will contribute to your final grade, okay? Because you need to complete the weekly assignments and I think they're worth 10% of your final grade. Okay. You also need Mobius and Maple for your lab tests, which you do at home. Okay. And the final exam too. Karen, I'll probably be putting up the lecture notes a week or so in advance. I'll try to do that anyway. All right. The lab tests, Abdurrahman, just look at the lab tests in the course pack, and they'll also tell you that they'll give you some practice exams too for the lab tests. So judging from the practice exams, you should be able to work out what's going to be in the real exam. All right, folks. Greetings of the day, namaste, zaijian, and thank you for chatting with me today. Time to say goodbye. Good job, Captain Bill, for the algebra. And behalf of the Yoshi and the Mario, I'll see you maybe at the tutorial today and maybe on Thursday. So have a great day and enjoy the semester and the term. All right, bye everyone.